already done the part 1 in the previous video. So you can go to the part 1. So all the basics, the formulas and all are given in that. So here we can see that given 10a is 4 by 3 and we have to find out the other trigonometric ratios of angle. So which are the other trigonometric ratios means we have to find there are 6 trigonometric ratios, that is sine, cos, tan, then it is cot, cosec and sec. So these are the trigonometric ratios. So let us see one by one first. Now it's given 10a is 4 by 3. So let us write this one. This is the rough diagram what I have drawn over here. So this here now since now 10a is just as wrote here, because here we have the angle, we want the of angle A. So the angle A should be here. So we can start A, B and C here because we want the ratios of the angle A. So this is the angle. So now 10A is 4 by 3 is given. So now you know that 10 is opposite by adjacent. So now you know here the hypotenuse is going to be here because this is 90 degree. The side opposite to this one 90 degrees the hypotenuse. So now this is the angle. So side opposite to this angle, that is the theta we can call. That is, this is the opposite side and this is the adjacent one. So we know that 10A means 10 is, here we have A. So that is here opposite by adjacent. So here what we can write here, we can write this is 4. So let us use the variable here as 4x and here let us use by 3x. So this is opposite and this is the adjacent. So 4 by 3. So see here, this I have written here, let BC is equal to 4x and AB is 3x. So hope this is clear. So now you know the Pythagoras theorem. So why you will find, because we know now the BC and AB. So we want this side. So this is the hypotenuse of it. So we will find out the AC with the help of the Pythagoras. So the Pythagoras theorem here is AC square is equal to AB square plus BC square. So we now here the AB is 3x, 4x. No, AB is here, 3x. So you write here 3x and you will take the square of that, and BC is 4x and then you will take the square of that. So now when you take like this, so what will you do? The square is for this as well as this, so that will be 9x square. This and this, that is going to be 16x square. So when you add this one, that is going to be 25x square. So AC square is 25x square. So AC is going to be, when you take the square root of this one, so that is going to be 25 is a perfect square and this x, so that is going to be 5x. So we got this AC as this is 5x. So now we got all the sides of it. So now we will find out all the trigonometric ratio. As I said, there are 6 trigonometric ratios. So let us go one by one. So sine is opposite. We can also write here side by hypotenuse. So that will be, we have the opposite here. This is 4x and this we got as 5x. So that will write here 4x by 5x. Our hypotenuse is 5x. So this x and x gets cancelled. So sine A is 4 by 5. Now let us see for the cos A. Cos A is adjacent by hypotenuse. So the adjacent over here, this is 3x. So that will be 3x and you know the hypotenuse is 5x. So that will be, this and this will get cancelled. That will be 3 by 5. And 10 is opposite by adjacent. So now we know here the opposite was 4x and the adjacent is 3x. So this and this gets cancelled. So 10a is 4 by 3. So that was also given in this one. So again we wrote because they want all the trigonometric ratio. And now let us see for the cosec. Cosec, the formula is 1 by sine A. So you already got sine A over here, that was 4 by 5. So you will write here 4 by 5 and this gets flip over because this is in the denominator. This gets flip over, so that will be 5 by 4. So cosec A is 5 by 4. So sec A is cos A. So you know what is cos, what did you get here? That you got is 3 by 5. So you will write it 3 by 5 and when it gets flip over, that is going to be 5 by 3. And one more thing, how to remember this cos. This sec is cos A. You can just go in this way also. You can go in the reverse order. And this, let us consider this as O. So this is cos, sec A is cos A. So many times there is a confusion. What will be sec? There is a confusion between the cosec and sec. So cosec is sine A, 1 by sine A, and sec is 1 by cos A. So now you have cot A. Cot A is 1 by 10. So now you got the value of this 10 over here. That is 4 by 3. You already, even it's given in the question over here. So now that will be 4 by 3. This is in the denominator. So this is going to get flip over. So that will be 3 by 4. So now all the 6, you have got the 6, this trigonometric ratios. So this is done. So now let us see the next question here. If this one, angle B and angle Q are acute angles and such that sine B is equal to sine Q, then you have to prove that angle B is equal to angle Q here. So now see here, these are the two diagrams over here. Then they said here that this is angle B is equal to angle Q. So this angle should be here and this should be here. So this, let us write this B over here. So let us write randomly A, this B and C. And here, what is it that? Because we know this is angle Q. So here angle. So now PQR, we can just give it this name as PQR. And now what will we consider? These are the two right angles. So same thing, the explanation is given over here. Let us consider two right triangles, ABC and PQR. So now let us make two columns over here. So that is for, we'll see for triangle ABC and for triangle PQR. So in triangle, this one, they have asked for the sine B, this is given, sine B is equal to sine Q. So we'll let us start from that one, sine B. Sine B means this is going to be here. And you know sine is what? Opposite by hypotenuse over here. So now what is the this one opposite is AC. This is opposite is AC and the hypotenuse is AB. So that is written over here. Now let us see for PQR. This is what the opposite is PR and the hypotenuse here. This is the hypotenuse, that is PQ. So now what we can see here, that since it is given here, what is given in the question, that sine B is sine Q. So sine B is sine Q, that is given over here. So what will you write? Sine B, you got AC by AB. So you will write it AC by B for this one. And for sine Q, what is that? PR by PQ. So this also we can make it rearrange that. This AC will be as it is. This PR, if you cross multiply here, it will come over here. And this AB will go over here and PQ is as it is. So now what we can do here, AC by PR, this both are same. That is, let us consider one variable, that AC by PR is equal to AB by PQ, that is K. You can put any variable over here. So now what we can see now, if we take this and this one, so AC by PR, that will be K. And if you take this and this, so what will be that? AB by PQ, that is K. So let us consider this as equation number 1. So now what we can do here, when we multiply this one, so what will you get? AC will be K, this K into PR. And when you multiply this one, so what will you get here? AB is K PQ. Now we are going to use the Pythagoras theorem for here for finding out this one. In triangle, this again here you will divide it into two groups. So here in triangle PQR and this triangle ABC and PQR. So now what will you do here? That is in triangle ABC. ABC, what we have by the Pythagoras theorem means this hypotenuse square is equal to base square plus height square, or you can write I square plus base square, both is the same. So here AB square. So this is here AB square is AC square plus BC square. So now when you rearrange this one, so what will you get here? AC, you will bring it on this side. AB minus AC square, that is here, this is BC square. So now we want the BC. What is BC? BC will be when you square both sides, you will get this thing as root of AB square minus AC square. Same over here. Now what we can see, the hypotenuse is here PQ. So we'll take here PQ square is PR square plus QR square. So now we'll bring this over here. That will be PQ is as it is. When you bring this over this here, on the left hand side, it is going to be minus over here. That is PR square is QR square. So now we want QR. This is the square of it. So when we square both sides, so what is that going to be? QR is going to be root of PQ square minus PR square. So now what we can do now, this is BC and this is QR. So you can divide it that BC by QR. So what are you going to write? BC means this one, you will write it over here. And QR means this, you are going to write it in the denominator. So now what we can do here, we know BC by QR means we have seen that AB in the equation number 1. So what is that? This is, we have considered this here, this, now see here, this we want for AB. So what was AB? AB was K PQ square. So this is K PQ square. This is minus as it is. What was AC? AC was K PR. So K PR, but this is square. So we are writing over here square and you have to put a bracket. Again here now the denominator, let us keep as it is. That is root of same over here. So now when we solve this one, this will be as it is. So when we solve, this is a square is for this as well as this as well as this. So what will you get here? In the first one, you will get k square pq square minus here k square pr square. And this, the denominator is going to be as it is. Now here this will be pc by qr, and that is, you will take from, see, this is one term and this is the other term. So you will take from this, what you can see is k square is common over here. So you will write a pq square minus pr square, and this is will be as it is. So now look at here, bc by qr, same, this one you are going to write here. So now when you take the root, see, this also is a square, and when you take here, so what will be that root will go off, because this here there is a square and the root. So that will be just k. So now this is going to be in the root. This will be outside the root, and this will be in the root. And this, the denominator is the same. So now what we can see, these both are the same. So we can cancel this one. So what we can write, this we can write as k. So let us consider this as equation number 2. So what was the equation number 1? Was this one, and the equation number 2 is this one. So from 1 and 2, what we can see, that when you compare these two, what we can see, AC by PR is K, and here what we can see AC by PR is equal to AB by PQ, and which is BC by QR, and which is K. So all three you are going to bring it together. So now what we can do here, so we can write here AC by PR is equal to AB by PQ is equal to BC by QR. So here, now see here, when we compare this, means this side is equal to this one, this is going to be equal to this one, and this is going to be this one. So from that, what we can say, that corresponding sides of triangle ABC and PQR are in the same ratio. Therefore, triangle ABC is congruent to triangle PQR. So now what did they ask here? They asked is, you have to find, then we have to prove that angle B is equal to angle Q. So now from this one, we got this triangle the same. So now you see, whenever there is a, whether there are ABC, means you have to consider the middle one is the angle. When we write here ABC, when I write here, so middle is the angle over here. So that means we can also write this as angle B, and here PQR means this, we are going to consider this Q. So that is angle Q. So we can write here angle B is equal to angle Q. So that is, we have to write this one, hence proved, because we have to prove it. So the next one, consider triangle ACB, right angled at C. When they say right angled at C, just I'll tell you what it is, in which AB is 29 units and BC is 21 units, and angle ABC is equal to theta. So we have to determine the value of cos square theta plus sin square theta. So when we say right angled at C, so how are we going to draw the diagram here? So see, this is when you take this one triangle over here. So this one, so here there should be C. And then we want the theta. Theta means this is going to be ACB. This we have drawn over here. So we can also write this A, here B, and here C. So now, because here they said angle ABC is theta. So when they say angle ABC is theta, means then on the B side there should be theta. So we'll consider this as B and not A. So here should be theta. So now look at here, consider triangle ACB we have. When we consider this ACB, so what we have, this is the hypotenuse, right? So this side, opposite to this is the opposite side to theta, and this will be the adjacent one. So what we are going to write, AB square is AC square, this is the AC square, and this is the BC square. So now what we have, they have given the value of AB as 29 units. So let us write that 29 below this one, that is the square of that. So we don't know AC, but we know BC as well. So what is given here? BC is 21 units. So let us write here, this is a square, so you will write a 21 square. So now look, this will be as it is. When you take this one on the other side, that is going to be minus 21 square, and this is going to be as it is. So now see here, we want only AC and not square. So we are going to square both sides. So when we square both sides, so this will be AC and this will go in the square root. So now this is in the form of A square minus B square. So you know the formula, A square minus B square is A minus B and A plus B. So this is A and this is B. So you are going to write here, or you can also write as A plus B and A minus B. Both is the same. Because see, 5 into 3 also is 15, and 3 into 5 also is 15. So you can write, whenever the multiplication, you can write it anyways. So 29 plus 21, and here 29 minus 21, that is AC. So now what will be here? This is going to be 50 and this is going to be 8, that is AC, and when you multiply this into this, that is going to be 400. And now you know the 400 is a perfect square, that is 20 into 20, that will be 400. So root of 400, that is going to be 20. So that is AC. So you can write here AC is 20 units, because we don't know whether it's in centimeter, meter. So, but this writing units is important. So now what is the other thing? They have asked for the value of, determine the value of cos square theta plus sin square theta. So let us see first what is sin theta. Sin theta is opposite. You can also write this as here side by hypotenuse. So now look at here, which is the opposite over here. This is theta. This is opposite one divided by this one. This is the hypotenuse. So now what did you get for AC? AC we got this as 20. So this is 20 over here, and so we can write here this AC divided by this AB is 29. We already have this one, that is AB is 29. So this is 29, this is 20, and this is 21. So we got all the three values. And then so it is sin theta is 20 by 29. So cos theta is what? Adjacent side divided by the hypotenuse. So what is adjacent? Adjacent is this BC. So this BC is what? That is 21. We already have over here. So that will be 21 over 29. So now we want the value of this one. So we got sine and cos theta. We want the value of cos square theta plus sin square theta. So just square it. Just write a cos square theta plus sin square theta, means you got the value of sine theta as 20 by 29. So you are going to write here sine theta is, yeah, so you want the cos square theta plus sin square theta, sorry. So this will be 21 by 29, because this is 21 by 29 and the square of that one. And sine is 20 by 29. You have to take the square of this one. So now what you can do, you're going to multiply this into this into this. That is 21 into 21 and 29 into 21. So you can write this 2 times. And again the same over here. This you are going to write it 2 times. Either you put your single, or you can make it separate. Both is the same. Now see here, in this both part, what you can see, this is one term and this is the other term. So you can see this 29 2 times. Here also the 29 2 times. So that will be, nothing is in the denominator, means you can write a 1 divided by 29 square. And what remains is 21 into 21, that is 441, plus 20 into 20 is 400. So you will write a 1 by 29 square, and this when you add it, you get 841. So now you can see 29, this is 1 by 29 into 29, that is 841 into this will be the same. So this and this gets cancelled, that is going to be 1. So 1 into 1, that is 1. So the answer is 1. So in the next one now, in a right triangle ABC, right angled at B, if tan A is 1, then verify that 2 sine A cos A is 1. So now it is right angled at B. So now I told you before, see here. So here there should be B, because whenever you have here this one, so this right angle should be here. So here should be B. So you can just write here A, B and C. So now let us see how to do it. Now we have this triangle, that is in triangle ABC. So now what we have, it is given here, if this is tan A is 1. So let us start from this one. So tan A is opposite side divided by adjacent one. And tan A is given as 1. So below this tan A, we are going to write 1. And this opposite is here. So this is theta. So now look at your opposite side by hypotenuse. So for this one, so you know this, yeah. So we want for A. So A is here, because this 10A. So for this one, the opposite side is going to be, this is the opposite side. So wherever the angle is, and this is going to be the adjacent side. So be careful for this one, because the A is over here, and this is going to be the hypotenuse. Definitely wherever the opposite to 90 degrees is going to be the hypotenuse, because, but since A is here, this is going to be the opposite side, and this is going to be the adjacent side. So here, opposite side divided by, that is going to be BC, and the adjacent is here AB. Hope you got this point. So now when you multiply this one, that is going to be AB into 1, that is AB is going to be BC. So this one, AB is going to be BC. These both are going to be equal. So now look at here, when we say let AB, let us put one variable over here, that AB is equal to BC, that is K. So now what will you do? AC square. This you are going to take, that is going to be AB square plus BC square by the help of the Pythagoras theorem. So AC square is equal to AB square plus BC square. So now what will you do? We just want AC, so you are going to squaring both sides. So this you are going to get, this will be in the square root. So now we have considered this AB is equal to BC is equal to K. So in place of this AB, we are going to put this K, so that is the square of that. Again, the BC also is K, so we are going to take the square of this one. So what will you get here? So K square plus K square. So there is also 1 over here, there is 1 over here. That is going to be 1 plus 1, that is going to be 2K square. So now this AC is, now see here, this K square, root of K square. Root of K square is going to be K. So K will go out of the root and you will get root 2. 2 will be inside the root. So this we got as AC, we got as K root 2. So now we want, what did they ask here? Verify that 2 sine A cos A is 1. So let us find the value of sine A first and then the cos A. So now you know this is opposite side by hypotenuse. So what is the opposite side over here? That is BC, because this is A, so this was opposite side BC by the hypotenuse. So BC by AC. So now what did we get BC over here? BC is K. So let us write this K over here, and we got AC as K root 2. So we'll write a K root 2. So this K and K gets cancelled and we get here, just remains is root 2. So that nothing is over here means that is 1. So the value of sine A is 1 by root 2. And cos A is adjacent side by hypotenuse. So now which is the adjacent over here? That is AB. So here what we'll write here? AB, and the hypotenuse is AC. So again now we can see over here that is AB is K. So let us write in place of this AB as K, and the AC is K root 2. We already got the value, this as AC as K root 2. So again this and this gets cancelled. So here we get 1 by root 2. So cos A also is 1 by root 2. So now what we have to see, that we have to verify that 2 sine A cos A is 1. So what will we do? We are just going to put the values over here, because since we got sine A and cos A, so 2 will write as it is. This in place of sine A, we are going to write here 1 by root 2. In cos A, we are going to write here 1 by root 2. And this 2 is going to be the same. And this is going to be 1. And root 2 into root 2 is going to be root of 4. So that is going to be 2 into 1. This is same. Root of 4 is 2. So this will be 2. So now this and this gets cancelled. So that is 1. So now that is proved. Now we got here 2 sine A cos A, that is 1. So we can say 2 sine A cos A is equal to 1. This we had to write hence verified. Like whenever that hence proved, hence verified, this is important over here. So in the next year, they said in triangle OPQ, right angle at P, OP is equal to 7 centimeter and OQ minus PQ, that is 1 centimeter. And you have to determine the values of sine Q and cos Q. Now look at here. Here, because they said right angle at P, this is very important. So the right angle should be here, and here you should write P. And now they have said, so it can be anything P, and this one, yes, when this OPQ, right angle at P, and OP is given as 7. So now here you can write this is OP, that is given as 7. So now let us see OPQ. So in OPQ what we have, that this is the hypotenuse, right? Because this is the 90 degree, this is the hypotenuse. So now let us see OQ, that is the hypotenuse square, by using the Pythagoras theorem. So that will be, this is the base, that is the OP square, plus this is the height. So that is also, we say the perpendicular side. This is also called as the perpendicular side. That is the PQ square. So now what will you do here? This you will write as it is, but this PQ square, if you take on this side, this is plus. So this is going to be minus PQ square. And this OP square is going to be as it is. So now what we can write here, that it's given over here, OQ minus PQ is 1. So here what we can write here, OQ minus PQ is 1. So now see here, OQ minus PQ is 1. So that we can also write this as OQ is equal to PQ, because this minus PQ goes on that side. So that is going to be, this means both are equal. So in place of this one, what we can write here, OQ, this one PQ, and this we are going to write over here, PQ plus 1. So here, look at here. OQ, or we can also write here OQ is equal to 1 plus, we can put this value as 1 plus PQ. This will go on the other side, so that is going to be 1 plus PQ. So now in place of OQ, yeah, so we can write a PQ plus 1, and this is the square, so we will write a square of this one, and this will be as it is, and this will be also as it is. So it is also given over here, OQ minus PQ is 1. So now what will you do? This is in the form of A plus B whole bracket square. So you know the formula for A plus B whole bracket square, that is A square plus 2AB plus B square. So now what is this? Is A, this is B, this is plus. So you are going to take the square of this one PQ, that is PQ square. Twice AB means 2 into P, this is A and this is B. So this PQ into 1, that is going to be PQ here. And this is the B square. B square means this is 1. 1 square is going to be 1. So this now, what will you do? This minus PQ, you are going to take in the other side. So that is going to be, here you will write your OP square, and this is going to be plus. So now look at here. This will write as it is here. And this PQ square, you will take it on the right hand side. So this will be as it is, this is as it is, and that PQ square is over here. So minus PQ square. So now here this is going to be same, 2PQ plus 1, and here with this and this gets cancelled, that is going to be OP square. So 2PQ plus 1, that is now the value of OP is given. Can you see here? OP is 7. So here this is OP square, so that we can take as 7 square. So this will write again the same, 7 square is 49. So 2PQ here, 49 as it is, and plus 1 is going to be minus 1. So 2PQ is going to be, this will be 48. And now you know this 2PQ means there's a multiplication sign over here. So PQ is going to be 48, this as it is, and this is going to get divided. So PQ is going to be here 2 ones are, and this is 24. So PQ is 24. So now we got PQ. So now let us plug it in this one. And this, so OQ minus PQ is 1. So now let us write the same thing over here, and in place of this OQ as it is, in place of this PQ, we are going to write here 24, because we got here 24, and that is 1. So now OQ will be as it is here, and this one on the right hand side, but minus 24, it will go to the other side, that is going to be plus 24. So this, when you add this both, so that is 25. So we got the value of OQ as 25. So this, we got now all the sides. Now what is the main thing remaining over here? That we have to find the values of sine q and cos q. So this is, after getting all this, we got the values over here, means what are the sides, we got all the sides of it, and now we are going to find out what is sine q and cos q. Now you know the sine q is what? This will be opposite side by hypotenuse. You can also write if you want this one. So what is the opposite over here? That is OP. Because we want the sine q means you are going to consider this angle. The opposite is going to be this side. See here, because they have asked for the sine q, so this is the angle. The opposite is going to be this one, and this adjacent is going, the hypotenuse is not going to change, because the hypotenuse is always the side opposite to the 90 degree. So that will be OP by PQ. So can you see here, OP by OQ, or Q, this one you can write both. Now we got OP. OP we have as 7, and you got OQ as 25. So you will write it 7 by 24. Hope this is clear. So now cos Q. Cos Q is adjacent side by hypotenuse. So now you know what is the adjacent over here. So that is PQ. PQ is the adjacent side. So you can write here PQ by, this is the hypotenuse. So now what is PQ over here? PQ is 24. You got here PQ as 24. So you will write here in place of PQ as 24, and the hypotenuse, this is the OQ as 25. You have the OQ as 25. So we got the values of sine q and cos q. So the next one, they said that given 15 cot A is 8, and you have to find the sine A and sec A. So now look at here, when we draw this one, so we want, this will take this ABC. So here, this is 90 degrees, so this is going to be the hypotenuse over here, and we want sine A. Sine A means, now see here, if we are taking this A, so this is going to be the opposite side, and this is going to be the adjacent side. So now, this is the given 15 cot A is 8. So 15 cot A is 8 means cot A is going to be this 8, and this 15 is going to go in the denominator. So cot A is what? Cot A is, see here, 10 you know, sine is opposite by hypotenuse. Cos is adjacent by hypotenuse. And the tan is opposite by adjacent. So this cot is 1 by 10. So what is going to be adjacent is going to be, it is going to get flip over. Cot is 1 by 10. So just remember this, cot is 1 by 10. So this opposite by adjacent is for 10. So this is going to get flip over. So adjacent will go in the numerator and the opposite is going to be in the denominator. So hope this point is clear to you. So now we have cot A is 8 by 15. So this is 8 by 15. And now what we have here adjacent over here, that is AB. So we are going to write AB over here. And opposite is what? This BC. So this BC we'll write here. So now what will you do? Now you will consider this and this and this and this. So AB is, we can consider this 8K. Let us write this variable. And this BC, let us write this as 15K. So now according to the Pythagoras theorem, what we can see, which is the hypotenuse here, AC square is equal to base square plus this perpendicular side square. So AC square is AB square plus BC square. Now you know what is AB. AB is K, 8K. So 8K square of that one. And this is BC is 15K square of that. So now this AC square will be this into this. You have to be very careful over here. This into this, this into this, this into this. So 8 square is going to be 64. And this is going to be k square, and this plus sign as it is. 15 square is going to be 225, and this is going to be k square. So AC square is, when you add this one, that is going to be 289 k square. So when we square both sides, so AC is going to be, this is a perfect square, that is of 17. You can just check here. 17 into 17, that is going to be 289. So this is k square, means we are going to square, that is going to be k. So we got AC as 17k. So now these things are, we got all the values of the sides. Now we are going to think, what did they ask here? They asked what is, you have to find out sine A and sec A. So sine means what? That is the opposite side divided by hypotenuse. So what is the opposite over here? Sine A. A is here. So this is the opposite. So here you are going to consider BC, and this is the hypotenuse, that is AC. So you can write here BC by AC, and then you know the values of BC. What is that? BC is 15K. And what is AC is 17K. So 15K and 17K. So this K and K, because this is multiplication, K and K gets cancelled. So your sine A is 15 by 17. Now sec A. So sec is nothing but 1 by cos. So you know cos is adjacent by hypotenuse. So here when we write the sec, that is going to get flip over. So hypotenuse will go in the numerator and adjacent will come in the denominator. So that is what I wrote, hypotenuse by adjacent side. So now look at here, what is the hypotenuse we have here? That is 17K. And what is the adjacent side over here? Adjacent is 8K. So you will write a 8K. So this K and K gets cancelled. So sec A is 17 by 8. So by this we have completed today's work. Do like and subscribe to my channel so you get a notification of the other parts. Thank you.